Well, can everybody see my my Word document here?
Yes.
Okay, I'm going to try to, like I said, Brandon Phillips was supposed to be doing the note taking for me, and he is ill. So I'm going to be both facilitator and note taker here. So I'll try to keep an eye on the chat if you want to raise your hand or just sing out. We don't have too many people in here. It shouldn't be too chaotic. So these were some of the questions that were covered during the breakout session itself. And pretty straightforward, I think. Do we have any other questions that we want to address about the lunar environment and effects on materials? So I'll start with one with where are the gaps in our knowledge right now?
Well, I've got one to contribute to that.
Okay.
We don't know what the materials are that they're going to be using for these lunar habs. We don't know what the clothing are yet. We don't know what the construction materials are yet. So how can we tell how they're going to age in the lunar environment?
Mm-hmm. And I would think that, you know, we've more got a list of, well, don't use this than do. You know, we've seen failures and peeling and darkening and all the other things. And sometimes even when you know it's going to darken, like for example, the thermal control coatings. If you've got a complicated surface to paint, the ceramic paints are going to flake and chip and so forth. And it's a whole lot easier to put on like a low outgassing silicone binder paint, like the S13 GLO and ones like that. But you know they're going to turn brown, and you just hit because it's going to be hard enough to paint and make it stick, and you just deal with the change in solar absorptance over time.
So I have a question related to that. It's not an answer. I'm probably one of the few non-materials researchers in the audience, and I'm wondering, like, if we compare a test facility or an exposure facility, kind of like Missy, what would we like to see in terms of observational capabilities, and what would the durations of them be? And part of why I'm asking this is if we're looking at CLIPS missions, right? None of them are currently talking about surviving, a lunar day. Surviving, a full lunar day, right, past the illuminated period into lunar night. So what do we think would be interesting in terms of lunar exposure facilities, assuming that we're not going back to that same location, so we can provide some requirements back to STMD?
Also, adding to the scope, like for example, dragging materials through the harsh dust would be nice.
So that's the next question. What types of tests would you like to see in situ, right?
And that's one thing where they're not really dragging the material through the regolith, but the regolith adhesion characterization at least should get, some of the churned up dust during landing. Which I think there's actually two phases of exposure, where you've got one that will look at the churning during landing, and one that's just normal moon operations.
I have two comments. One, Marshall is building a dirty lunar exposure chamber. Dirty because it's got lunar dust incorporated into the environment. And when is that coming online, Maria? Do you?
I think it's online. It's Paul Craven that's been doing that testing, and I'll have to see where we're at with that. But yeah, there's some. It's got not only the dust, but vacuum ultraviolet radiation, protons, electrons. It's got.
Is that the one that DeWitt was mentioning earlier?
That's correct.
Yeah, I pinged him during the meeting. It looks like they're already operational, and Dave Edwards is in the audience.
Uh-huh.
Sheila, I'll forward you the slides they sent me, and I'm trying to coerce him to talk to a forum for NASA.
Right. Well, I mean, that facility, I mean, in the past, we tried to have no contamination anywhere, and now we specifically need the dust because it is an environmental parameter. And so I think that the Marshall system is, going to be very valuable to us. My other comment is with regard to the materials and the dust on the lunar surface, when there's a landing, apparently there's a plume of dust that's quite high velocity. And so this creates impact damage to the surface. I mean, not just, dust adhering, but high velocity, hard particles hitting the surface.
Like sandblasting.
Yes, that's an excellent way to describe it.
Hey Sheila, there's a project right now within our science and technology office called plume surface impingement, I think is the name of it, PSI, and that they are studying regolith impingement. What they're not particularly focused on the impact and the damage, more so modeling the plume that comes out whenever landing craft land on the lunar surface. So that'll certainly help us to define that plume environment that can help to guide our test.
Okay, that sounds very important.
Hey, Maria, let me throw something out here.
Sure.
It may not be appropriate for this forum, but I'm going to give it a shot. I remember 100 years ago when I was doing this kind of testing, there was always an issue about accelerated testing. And since this is for I'll say the science community, would it be appropriate to investigate, I'll say, accelerated testing versus real-time testing, and see if there's some way to converge on that?
Okay, something happened here. Does that capture that well enough?
I think it does.
Okay. And for that one, I would say it's probably very dependent on the material, and especially if you got to control the heating.
I would agree. There's a number of variables in that. Yes.
Because yeah, if you start heating up the sample more than, and especially more than it would see in space, then all bets are off.
Yeah, I agree. One place where we might be able to get some accelerated testing for radiation might be the NASA Space Radiation Laboratory in Brookhaven National Lab. They do have protons, and they now have a GCR simulator. The particles are really in sequence rather than simultaneous, but they can do multiple particles back to back during the exposure. But that is accelerated, and it's expensive. And one reason it's expensive is that they typically are set up to look for the transport of radiation through the material. And that's not really what we are interested in this session. We're interested in how the radiation damages the material over time. So therefore, you've got to run it for a while. Even if it's accelerated, you've got to run it for a while, which makes it expensive. If you're just trying to see if the radiation will transport through, that doesn't take very long.
You can only accelerate so much.
Right. And of course, there are other facilities too. And then Marshall has some facilities for protons and electrons and ultraviolet.
We do, but we only go up to, I want to say it's 2 MeV electrons and 700, 750 keV for protons.
Yeah, that's I believe that's accurate, Miria. Last I recall.
Yeah. Because that was, we were working with one of the small business innovative research companies on radiation shielding. And we just didn't have anything powerful enough to go through what they had designed, which is, that's good, but, you can't really test how well a radiation shield material performs if it's not enough energy to go through, if the first layer stopped it, then that doesn't really tell you much about the whole stack.
And also, when I ask questions about, well, how long are we going to be there? I mean, most people I talk to talk about what we're going to do next, which is going to be kind of short. Not as short as Apollo, but short. Yet the overall plan is to have a sustained presence, to have material structures that are going to be up there for a long period of time. So we only have to take them up once or build them once. And when I ask questions, I don't seem to get a good feel for that. People are focused on, the early missions. And the materials are probably going to hold up for these short early missions. But for a long mission, like, we're hoping for sustainability, that's a different issue. And that, we need to be looking at that too. I don't see a whole lot of activity now looking at that.
Well, there's got to be some lessons learned from space station on that, especially with the solar arrays.
Yes, yes.
Because we went through, first it was 30 years, then it was 15, and then it was 20, and now we're extending out from 20 to now what, 23, 25, and it's probably going to end up being right back at 30.
The Russian Mir had problems with solar arrays.
Yeah. Well, I remember Johnny Golden saying that the solar arrays lose about 1.5% power per year due to radiation effects. And those are the big, thick cover glass silicon solar cells that are about 12% efficiency. So, what does that mean for your triple junction 36% efficient solar cells with either no cover glass or very thin cover glass?
Yeah, and then there's the substrate onto which they put the solar cells. I mean, which is typically some kind of thin film, like Kapton or whatever.
Mm-hmm.
And that doesn't last forever in the radiation environment, UV environment.
Well, I know they did some tests for Juno for the Jupiter radiation environment, and I'm not sure how much of that actually got published, but I know the data has to be out there somewhere.
And we're working more and more toward having thin substrates so that the solar arrays can be rolled up,
Right.
For launch and then deployed.
Well, and then that leads back to the meteoroid impacts.
Yes.
What's your terror resistance if you get a great big hole in it, or a lot of little holes?
Yeah, I think the films are vulnerable. The coatings, the paintings. To a certain extent, the adhesives might be vulnerable if you've got penetrating radiation. And organic adhesives, which we have.
I know sensors are often, I don't know if that goes in here, sensors are often pretty vulnerable to radiation damage as well. We're always losing our cameras on ISS, or pixels on the cameras.
Okay, so there's a question in chat about the deployable solar arrays on space station. Yes, in fact, I think they've already deployed 2 of those. I saw a picture with at least 2 of them deployed. And that is the rollout solar array.
Yeah, I work with Redwire, and Redwire's a kind of a conglomeration of a bunch of different companies. I'm actually with Deep Space Systems, but I know that one of our sister companies built those solar arrays, and that I hadn't heard yet if they had deployed them or not. And I was just curious if I probably could talk to somebody in my company, but since I'm here, I'm curious to know if anybody has any opinion about those solar arrays versus what's currently on ISS. Obviously, it'll be an upgrade because of they're new and what you just mentioned about the degradation over time. So I think aren't they also bigger and going to provide more power beyond just because of the new efficiency as well?
There is a lot more power from them for a lot less space.
So do you think that the materials that they've used are going to have similar issues as the ones that are currently there in terms of the degradation? Or
I know we've done testing, but and here it comes back to, you've been doing things in sequence. What does it mean when they're all synergistic? How accurate are our simulations? Are we within 10%, or are we, not even close? Hopefully we're within that 10%. That's at least one thing that I strive for.
do you know if there's any opportunity to bring back some portion of the solar arrays that are currently up there, or is there any, I don't know what they're doing to decommission them. I imagine they have to deploy these other ones over the top of them, I would think, but I mean, I don't.
They did, and I don't expect them to bring it back. We don't have a shuttle, and I don't think there's enough room in the Dragon trunk to bring it back. We would have to have some other vehicle to bring them back.
Or like just a portion, I mean, like, I don't know if there's a way to take a sample or just a portion of a panel. Would that be of value to everybody to get that?
Oh, yeah.
There so
We
long?
did that with the mirror. We brought back a solar part of a solar array from Mir after 10 years in space.
Interesting. Okay. Yeah, it seems like a natural experiment to see if there's a way to get a small piece back. That would seems like in this conversation would be of interest and value.
Yeah.
I think they shield the radiators as well from the sun, so they would have to, at least most of them would have to stay just to block the sun from hitting the radiator panels.
I didn't know they did that. I knew the solar rays rotated to follow the sun.
Yeah, I think getting rid of heat is one of their biggest concerns on the space station.
It is, and so Dave Edwards and I did the testing for the thermal control material for those radiators. And that was one thing that we learned from the Mir space station was you have to control the contamination. And maybe that's another thing I should add in is contamination control on the moon other than dust. Because that one of the things that we learned, we were line of sight to a stowed Russian solar array that had a great deal of unbaked, very outgassy silicone, not silicon. And the closest edge in line of sight to that solar array received between 5 and 10,000 angstroms of silicone contamination, which you can imagine how much havoc that wreaked on optics and thermal control materials and so forth. I mean, it was so thick it was spalling off. And we realized that if we didn't control contamination on space station, that we were going to have to replace those radiators every 2 years. And nobody wanted to do that. How
did the contamination migrate to the other locations?
It outgassed, and since it was line of sight and we were in the way, so just this cloud. The other thing is because of the higher inclination of the Mir than what we were used to seeing from early shuttle flights at 51 degrees inclination. Every now and then you'll get a few days of 0 time and shadow, and everything heats up. And so whenever we would go through one of those, then you could see on the quartz crystal microbalances on the experiment that we just got hammered with a lot of radiation. And some of it would outgas back off once everything cooled off a little bit and it didn't stick. But you get enough atomic oxygen in synergism with that silicone contamination, you've got a big thick layer of silicate, and you can't clean it off.
Also not sure if they are they planning to use radiators on the lunar surface, or will they try to just sink it into the moon crust or something?
Well, for rovers, I know that they're going to have to use either radiators or some kind of other active control. Obviously, right, they won't be stationary to be able to do that.
Hey, Maria, a little bit of a different topic, maybe.
Okay.
There's been some talk about manufacturing using regolith to make outfitting parts and things like that. And so the question has come up, what would be the space environmental effects on the material and structural properties of these components that are manufactured from regolith?
Well, I actually have an answer for that. Let me finish typing. So, Sabayu Sen here at Marshall, back with Missy 6, combined lunar regolith with polyethylene and also Mars regolith with polyethylene in different percentages to see how well it held up on the wake side. So not a lot of atomic oxygen, and at least the UV and the thermal cycling, with the idea that with the polyethylene you get some radiation shielding with that. So you could make, big bricks for radiation shielding and have the regolith protect the polyethylene from radiation effects in terms of the direct UV exposure, but still stop your galactic cosmic rays and electrons and protons, things like that.
How was the regolith distributed? Was it homogeneous?
Yeah,
sample, or was it layered?
it was homogeneous. It was all mixed in together. And like I said, he looked at different, I think it was by volume of how much polyethylene he incorporated.
Interesting. Thanks.
So, and yeah, it was the JSC 1A for the lunar, and I don't remember for the Mars, but it was whatever is the standard one 10 years ago.
I actually have some data also. I have Martian regolith and 4 different polymers. Polyethylene was one of the 4, and mine were on Missy 10. And they held up. Now, I only had them on the nadir orientation. I was being a little timid because the last thing I wanted was for the material to break up and start contaminating everybody else on Missy.
Right.
I thought that would not be a good thing to do. So I deliberately put them on nadir, and I didn't shield them or cover them or anything. And that was Missy 10. But the 4 different polymers, I had 4 different ones, they all held up. I have made material with lunar regolith simulant, but I haven't ever flown it on Missy. But I would expect it to behave the same way. The polymer, if you're using the polymer for a binder, that would be the vulnerable thing.
Right. Yeah, I think my additive manufacturing samples were opposite yours on the Nader side on that mission.
Okay, yours were metals, where you had metals and polymers. We had
Yeah,
both.
I did.
You had both. Actually, I have another question that is an aside, but I mean, we all know about these CLIPS missions, and I don't know much, but I know they exist, and there was an excellent talk today, actually, in our session about, CLIPS. And, so they've got something like 14 different contractors, I think they said. And this is supported enthusiastically by STMD. I mean, are there any materials experiments that we could come up with and try to get on a CLIPS mission?
Sheila,
or three.
Sheila, so this is Kevin. We are actively working to define multiple materials experiments over a couple of different years, focused around long-term survivability, thermal management, nighttime survivability. There will be a mix of system and materials experiments. I think you saw in the presentation, maybe you didn't, right? Alpha Space, the folks that delivered MISSI Flight Facility, the current one that we have on ISS, they're flying on one of the early Eclipse missions, the RAC. It's the regolith something, I can't remember what it stands for, but it has to do with regolith accumulation.
Adherence characterization. In fact, I actually mentioned that in my talk. I am aware of that.
So Alpha Space also has a tipping point to develop a lunar deployable MISSI-like facility for materials experiments, right? So I think the RAC is a foray both to their materials, but also for them to understand CLIPS capabilities and what the challenges are. So I guess the punchline really is to stay tuned. We're actively working on that, and as we get a little bit more clearance to talk about what we're doing, and closer to a time so that it's not so far in the future that it's vaporware, we could do a workshop on what we think that needs to be. Mark Hilberger's the PT, and I'm the Tim working on it.
Okay, that's great.
And I'm the COR for that contract.
That's right. And you've been ignoring my email about how you guys are doing.
I didn't realize I was ignoring you. I'm sorry. Well, we hadn't gotten the contract signed until I think last week.
I know. I sent you the congratulations that afternoon.
Oh my word. That was, it should not have taken 8 months to get, anyway, that's not for this discussion. All good. But anyway.
So the point there is you've got, well, now you got three folks to have work on something for you, Sheila, but we're hoping for something pretty cool.
Okay, thank you. Sounds great.
How do you pronounce that, Maria?
The experiment or my name?
Well, I guess both. I feel like I just pronounced your name wrong.
You did. It's Miria. It's like Miriam without the M.
Okay.
Thinkanor.
And then Steph, do I stutter that?
I just say S-Steph.
Okay. Roger that.
Though in the hallway it's the Moon Missy.
Yeah, I've seen it as Lunar Missy, Moon Missy, and a couple other things, and it's like, well, they have a name, so.
Yeah. You said something else besides nighttime survivability, and I missed it. And I want to make sure that I captured that.
Oh yeah, so we're trying to figure out how do we get to the long-term survivability, and there are other aspects, right? So if you think about in terms of durations of mission, at least this is the way I've been trying to compartmentalize it, right? So the initial thing is how do we survive the heat of the lunar day, right, and the dust, and then as you start to go, how do you survive a lunar night and theoretically the dust, and as you're there longer, you care more about radiation. There's a tremendous uncertainty about the plasma environment, right? If you read some publications, it's going to be horrendous to deal with. We have no experience in the nighttime operations, the plasma environments, the shadowed electric charges in the shadow, et cetera. So the longer we're there, the more the confluence of these different environments are going to become a challenge that we really don't even understand. So that's sort of the expansion on it. But to me, it extends from nighttime to just long-term sustainable infrastructure.
So I've written myself a note to get back to you after this session is over and answer whatever questions you have about the contract.
It's all good.
I guess my question about the putting it onto a CLIPS lander, what kind of data do you need to receive back? Is imaging enough?
Probably not.
Or do you need a hammer as well to hit it with 10 years from now?
I guess it depends on what you're testing too, because well, and that's one thing I liked about Sheila's presentation earlier was with the pictures from Missy 9 and showing the degradation over time, being able to recognize, is it the same? Has it changed? And what are you seeing on orbit versus, we were fortunate enough with Missy to get the samples back. I don't know that we can count on that for the moon. It would be great if we did, but I'm not expecting that.
If you were to run an analog though, and then compare what they look like after a certain amount of time, that might be helpful.
Yeah. And things like your conductive thermal control coatings, being able to set that up as an active experiment and see, is it still conductive? What am I measuring now? And solar cell experiments, same kind of thing where you can do the power curves. And then one thing that I know that they have on the STEF is an environmental monitoring package. So we'll know at least how much UV, the thermal cycling. I don't know how they're doing the radiation monitoring just yet, but they know that they have to have something to be able to answer, okay, what radiation environment are these materials seeing? And, what does it take to degrade them?
On the solar panel point, now that these are commercial landers, is that degradation available to NASA, or is that considered proprietary now?
It's proprietary.
Oh, with the Rosa, yeah.
Well, I think he's talking for like the CLIPS landers. I've been asking constantly about how we can start asking for data, buying data, coercing them, right? And the CLIPS program is very guarded about preserving the proprietary aspects of the data to allow them to protect their competitive edge. The flip side is I want environmental data, right? Poor Heather. Heather's had her hand up for a long time.
Oh, I'm sorry.
You probably can't see it because you're sharing your screen.
Yeah.
Oh, no worries. I was just gonna wait until you guys were ready to move on to the next topic. So, it sounds like you wanted to finish that, and then maybe I can just. I have a totally different topic to ask a question about.
So if you're going to roadblocks on getting CLIPS data, proprietary and otherwise, so one of the things that's come to light is for our payloads at the end of the mission, it's not clear to me what the data rights are for those systems. And it's not clear to the people in the CLIPS program office in their answers that they know what the data rights are either, right? So
Well,
imagine
and that was some of what got me hung up with getting the contract in place with Alpha Space. Is they are keeping all the data rights for what their hardware and the software that they have developed, including what they're taking from the Missy Flight facility. And I was arguing that we at least need some kind of review before we launch to know that, number one, that there's no safety aspects that we need to worry about. You know, I have to be able to check that box, and I said so doesn't count.
yeah.
You know, I want somebody looking over their shoulder. Now, I'm perfectly willing to keep, keep whatever data in-house that they need, but we've got to be able to see the testing. We've got to be able to see the data, especially with as much money as we're spending on this, that to make sure that we're sending a good product to the moon, especially since NASA's not taking delivery of it. It's still Alpha Space's platform. And so we kind of went round and round on that one.
So the thing that, go ahead.
This whole legal thing, Kevin, I have a specimen on rack, and I got this document from Alpha Space that I was supposed to sign in a number of places. And it was kind of intimidating.
I hope you didn't sign it.
I actually did not. Now, Maria got one too, and
yeah, I didn't sign it either.
I didn't sign it. Sharon Miller got one. Sharon is at the Glenn Research Center. So we were all kind of sending emails back and forth, but not to Alpha Space. Like, what is this? So Sharon volunteered to seek legal advice with the Glenn attorneys. And I said, I'll just wait and see what they say. And the Glenn attorneys told Sharon that we should not sign it, and that it was not meant for we NASA people. And see, Sharon and Mary and myself were all NASA, and so I did not sign it. But there was a lot of you'll do this, you'll do that, with regard to me. And, it was a bit much. So, but that's a whole area. It's not a materials area. But the legal area, we have to make sure we're doing all that right.
It's going to be a challenge because I don't think that when they put the CLIPS contract in place, they didn't understand all the corner cases for the data rights. Specifically, right now we're launching missions, CLIPS landers with NASA payloads on them that are designed to operate for one lunar day. They're going to go into the night and theoretically they're going to die, right? Odds are one or more of those landers is going to operate the next day. They will have instrumentation attached to a NASA payload. Who owns the data associated with the instrumentation that's monitoring our quiescent, maybe still viable payload? And is there any avenues for us to then continue to try to partner and operate, right? And the answer is that, as of this morning, was completely unclear in what I got back from the CLIPS office. It sounds like as soon as sun sets, all that property and everything that's in it belongs to the vendor and it's theirs to do with.
My gosh,
that to me seems weird.
I'll send this to you, Kevin, for your
Don't send it to me. Don't send it to me. My answer is don't sign it. You're not an OUL.
I haven't. And it also went on, I don't have it in front of me, but I mean, it said other things like that, that I, Sheila, the PI, would promise that I would publish a paper within 6 months. And I'm thinking, well, maybe I don't have any data that's worth publishing. We have a Strive system we have to go through. That takes time. I mean, but it was like, I guarantee, I promise that I will, do this. And it was a short time frame. And I mean, it was just uncalled for, you know, and it was a number of pages and a number of things to sign again. So anyway, I have it, but I'm not going to send it back signed. And but this could get. Now I have a colleague at William and Mary, and they were going to fly on Alpha Space on Missy on the commercial side, and Alpha Space sent them a non-disclosure agreement for them to sign, promising they wouldn't disclose any information about Missy and Alpha Space. And they didn't sign it either. Now we NASA people have never gotten one of those NDE.
Sheila, do you want? We could talk more about this at another time. I think we're a little off topic from the.
Right. I agree. I agree.
I'll try to track you down next week. We can talk more about it.
This is useful for us too because we're working on a Eclipse payload, so it was good to hear this.
Oh, okay. I just felt sorry.
Like we didn't want to get too bogged down in the legalese.
Yeah, sorry.
So I don't know that we have an answer for this one, but yeah, I'll just say working on it.
I don't know if that was all the Eclipse contracts that it ends at the lunar night, but that's interesting because I hadn't heard that before, so I'll have to look into that.
I hadn't heard that either.
Yeah, I don't think they define it in terms of the ends of the lunar night. It ends at the end of the NASA mission, right? At least the task orders do. And all of the current NASA missions that are out there, Eclipse ones, are for a single lunar day because none of the vendors are signing up to operate in the night. Only Firefly has offered to go 5 hours into the night. That's as close as we've got to long-term exposure. So if you get a payload in, I'd say talk to your PIM about what the data rights are. And if you got any, make sure it's clear. We're trying to sort that out now. So.
I don't want to say something that is not absolutely true on this topic, but since I work with Deep Space Systems that is working with Firefly, I do know that they are working on some different battery capabilities for longer run times in the lunar night, and so I don't know if that's available yet, but it might be a capability that you would want to inquire about if you're going to be on that mission. And maybe that's already what the 5 hour is, but I thought I had heard a time a little bit longer than that possibly, and I could try to find out if somebody needs to know.
No, that'd be great if it's something you could share. For the NASA folks, I don't know that we could share if we knew any more. I don't know who in the audience isn't NASA.
Is there a time that the community is looking for specifically?
So my career goal is to have systems that last at least a year. Right now, it looks like other than Luna Node, which had nuclear, Surveyor operated for 4 lunar nights. At least one of them did.
And so you'd want to operate longer than that, or at least that long?
Longer than that, right? If we're talking sustainable, right? I mean, how do we get systems that could operate sort of ad nauseum? And I don't think we know how to do that yet.
Like the Mars landers, they lasted decades after their end date, and they just kept on going.
Right.
Yeah.
But it sounds like the target is like at least longer than 4 days.
Yeah.
Okay. Yeah, I'm not sure what the range is, but I'll see if I can message somebody. If I get an answer before the end of the session, I'll let you know.
Okay, Heather, what is your last name and who are you with, please?
Oh, sorry. Hava, Hava, and I'm with Deep Space Systems, or AKA Redwire.
Oh, nice.
And they're partners with the the Firefly for the Eclipse lander. And again, I don't want to speak out of turn as far as like I had heard some conversations about this, and so I was just trying to be helpful if it was something that I could inquire about and get an answer on. But since I have the floor, can I switch topics?
Yeah,
absolutely.
Okay. So this is definitely maybe completely off topic of this, maybe not. My question is, what my research is related to is bioregenerative life support systems, and I've been doing work with a product called Growstone, which is a foamed glass growth media. It's very similar to like if you're familiar with oh shoot, the name of it just jumped out of my head. It's perlite. There we go. So it's kind of like perlite in terms of it being really lightweight and porous. But the company Growstone actually recently went out of business, and I believe they have a patent on this. But I know that there are some other companies that are producing a similar thing. And what my question is related to is they use a foaming agent, and what I'm wondering is if there would be either like an opportunity for using lunar regolith to produce a similar product as Growstone. And I was just trying to, you guys were having this other conversation, look at the process, but I think, I know, for example, like with aerogels, they have to do a supercritical drying process, right, to basically in a vacuum to get out I forget exactly what the material's not my area, but I know that whatever the agent is, that's how they get it out of the material. So my question is, because you mentioned about it being a problem for off-gassing, if you wanted to use, the natural vacuum for a material manufacturing process, it sounds like that off-gassing of the volatiles would be a problem. And so if somebody was interested in doing that, do you just need to be like a distance away from the spacecraft, or like what would be the constraints to allow you to use that, or is that just a total no-go because it would be too uncontrolled and the chance of contaminating things around you would be too high of a probability?
I think it depends on what's coming off. So if it's like water vapor, I don't think anybody would care, unless it's well, I'll take that back. There's some like charge couple devices that are sensitive to water vapor. Everything else, I think it really depends on what's coming off and how much. Is it a little or a lot? And we kind of point it away from radiators and things like that, because it really is line of sight for contamination. That's a concern.
Okay, that's what I was wondering. So if it's line of sight, if you were potentially far enough away, and I guess that'd be fairly far away, whether that would be a feasible, if you had a small manufacturing plant, or, some of the things I've seen for, like, they were showing in the talk of, was it the gentleman that was showing, like, to get the water out of for the break the ice from mines with the tumbling kind of thing. If you had something like that that was far enough away, then possibly you could get away with doing that. I was just trying to think about, because I think I asked a question earlier when Dr. Schmidt about, how fertile could we use the regolith for growing, and I think those are opportunities that I don't know that have been fully explored, and I just I don't want to be proposing something that's an absolute no-go, but it sounds like it might be feasible. Just it's a it depends answer, and I don't know enough about the manufacturing process yet. But it's something I will circle back around, and to know that the volatiles coming off of it could be a problem is at least a good starting point.
Yeah, and that too, I think it would be especially the vent paths.
Right. Maybe it's a way.
There's ways around it, but yeah, if it's just sitting there and you don't want your radiator or your windows or something looking right at it.
Right, exactly. Okay, cool.
But yeah, we can handle that, I think.
Well,
That's
thanks for
interesting. I hadn't
entertaining my
thought about that.
off-topic question.
No, that's, hey, that's in situ resource utilization. So
Exactly, yeah. And I think it's a product that I've been working with for a long time, and I have always thought was a really good, like, because it's so lightweight compared to a lot of other growth medias that are being used, and it has such good like porosity and other properties that you want in a growth media. And so I just think that, you know, possibly being able to foam the basalt, you could get a product that would be similar to that, and it would be a reusable growth media once you make it. Growth stone is, you can, sorry, I'm getting hail here in Colorado. You get once you basically produce it, you can either re-sterilize it or just reuse it. And so I think it's something you could manufacture one time and then use it quite a lot before you need to make another batch. So that's why it would be a good opportunity to, if we could find a process for making it. But I'll mute now because I'm sure you guys are having a hard time hearing me.
and I just hope you're okay. That doesn't sound
Yeah,
good.
it's fine. It sounds worse than it really is.
I don't know. Reminds me of Captain Kangaroo with all the ping pong balls. Yeah, that's interesting. I hadn't thought about hydroponics using regolith. And interesting too with the, if you had used the natural radiation for sterilization. So one of the things that I'm supposed to do as note taker is write down who all is in this session. So I think I've got everybody off the Teams invite or the list here. Peter Navala, what company are you with, please?
Hello, can you hear me?
Yes.
Yes, I'm with Lockheed Martin Space here
Thank
in
you.
Denver. Yep.
I think I've got everybody. I'll try to keep an eye on and see if anybody else shows up in the talk. Let's see. In chat, is there another one? Oh, okay, Heather says you could use the vacuum for sterilization. That would also, something to know if it'd be an issue for off-gassing. Well, that would be, if it's off-gassing water, then filter it and get where the astronauts can use it. So that is, I had not thought about that for in situ resource utilization. Let me save this.
Hey, Miria,
Mhm.
something else just popped into my head, and it may be out of scope for this session. I'm trying to form the question in my head, but it's around planetary protection.
Right.
Obviously, the lunar environment's very hostile towards life, but will we have any planetary protection requirements? And then if so, how do those processes by which we sterilize the spacecraft, how does that affect the materials?
Okay.
Is that out of scope for this
No,
session?
that's that. Let me add that in. So, to my knowledge, there's no planetary protection plan for the moon. There is for Mars and Europa and things like that, but I think we all assume the moon is dead.
So
We're not going to find any bacteria.
They are adding in a section to the planetary protection planetary protection document, the NPR, I can't remember the number. There's a draft that's floating around now that has a categorization and a table in it that describe, but the punchline is basically you don't have to do anything. But for completeness, I think they're adding a category to clarify it.
Okay, thanks, Kevin.
I'll see if I could find that reference, but I know that I couldn't find it on my own. I found it buried in an email from somebody. So
Is it the Disney, the design?
no, there's a document out there that has the categorization for planetary protection, how you do that, and they added in it's like an L1 or something designation. That's just the back to the punchline being I don't think you really have to do anything because it's a dead planet. But
They're not going to use the Airstream trailer.
Well, it's coming up on 4:30. Have I got everything pretty well captured here? Do we need to, let's kind of rehash this a little bit?
I've got two little things. One, Lisa Scott Cornell was in our meeting at the beginning. So I don't know if you want to add her to the list.
Lisa
Scott Cornell. She's one of the program chairs.
Oh, yeah. Uh-huh.
Yeah, Lisa Scott Cornell. She was with us for a while on the front end. The other thing is technical. We don't really know very much about whether neutrons can cause damage because we typically ignore neutrons. Neutrons don't live very long in free space, but there are neutrons, albedo neutrons, coming off of the lunar surface, off of the Martian surface also. And we ignore them. I'm not sure we should be ignoring them. One thing is, I don't know if we even have a good feeling for what the neutron level is.
Hey, Sheila, there's a CLIPS experiment that'll be flying pretty soon. Once again, out of our science and technology office. It's called Neutron Measurements at the Lunar Surface, NMLS. And so that should give us at least an indication of what the neutron environment's going to be.
Okay, well, thank you. Thank you. I'm learning a lot today. I guess that's why we come to these workshops.
Yeah.
That's why, that is exactly why we meet, yes.
And that's something too, where we don't test a lot of materials for neutron damage. I would think a lot of what's out there is the nuclear power industry.
Right.
And so we would have to do some catch up on that. Which it's out there. There's at least some data on metals and composites. I don't think for not solar cells.
Right.
But, okay. So let me slide back up here, and I think we covered everything from the session itself. I don't think we ever answered, can we drag materials through dust? I think that is see the answer about the so we could do that. I'm not sure about different abrasion testing, but there's at least existing abrasion tests.
Hey, Mary, I joined just a few minutes after we got started. Did we capture meteoroid impact?
Talk to.
Not specifically.
Yeah.
But that would certainly be something.
Is that something where if you wanted to run a test, a real test on like Eclipse, you would need more than a day to wait around for a meteorite?
Yeah.
Yeah. I know we've got the Meteoroid Environment Office that is responsible to define the environment. Then we've got and the agency has several testing capabilities. But I think that's something that we need to understand and account for.
Well, yeah, and another thing, we really don't know anything about any possible synergistic effects when you include the dust. And you've got dust and ultraviolet and charged particles and temperature extremes, all simultaneously.
Well, that was something we were trying to work on here with having a meteoroid or a space debris impact on a solar cell in a plasma environment. Because you're looking for like one of those triggering impacts. So it doesn't just make a hole, but, fries the diode or breaks your solar array string.
Right.
So there was another topic I think we haven't discussed inside the habitat. They're going to be 35% oxygen, which degrades materials too.
Well, that's going to require a lot of retesting of some materials because we've done ones for 100% and for the, I guess, 20%. And I don't know of any testing that, or we need to catch up on that, I should say.
I agree.
And to complicate it, they I think it's 26% for the gateway and 35% for the surface. So they really want to give us some work to do.
And that's one that they probably just go ahead and do the 35% and not worry about the 26. I would think. That
they're different pressures too, though.
Yeah, the pressures are different.
Boy. We used to have the capability for testing that here. And is that all moved to White Sands now?
It is at White Sands. It's definitely at White Sands. I don't know where else it is.
I want to say it all has moved to White Sands, Amelia.
Well, we need to start testing now because it's, again, that's going to take some time to do all the materials for the habitat. Did we cover this one pretty well? The materials testing in situ with the Eclipse missions?
I'm not sure if we should be adding in what we expect them to do when humans are on the surface, if we're going to add that science in as well, but maybe that's too early.
I'm not following you. Oh, different materials testing that, like for tools or?
They can just get a lot more done when a human's there to lay out materials, collect materials, and then analyze on site, like in the glove box, for example.
So you're thinking about a laboratory inside the habitat?
Yeah, so there's supposed to be a science lab and at least I think 2 glove boxes. I think they said yesterday. So there's going to be a geology dedicated glove box, and then at least 1 science glove box, maybe a physical science and life science, just like the space station.
And then how soon would those facilities be available? You know, probably not on the first mission, or maybe on the first mission. I don't know. It would be worthwhile to have them on the first mission.
Well, and if nothing else, something where it wouldn't be any extra materials, but after they've done an EVA, look for abrasion on the spacesuits. How are the gloves holding up? Send back some pictures and kind of follow up with things like that where we expect to see either effects or how well are we mitigating the effects. And that's like one of the things from Space Station is just the photographic survey that they used to take after every shuttle mission was absolutely invaluable to see how things changed over time. And it wasn't really part of a materials experiment, but going back and seeing, okay, well, that's a little more brown than it was before.
And I'm sure the astronauts are going to find ways to break things that weren't even thought of.
Oh, yeah.
Actually, what about mechanisms? Is that being covered in some group, breakout group?
Like gaskets and pivot points and things like that.
Yeah, things that can get clogged up with dust and not work. I mean, there is a lunar environment problem. I'm sure there's going to be one with mechanisms because of the dust and lubricants.
Yeah, I think our talk earlier today said Schmidt said all of his geology equipment was useless after a few hours or something. All the joints were destroyed.
Right. And the joints in the spacesuits had problems also. And seals could be a problem. I mean, this dust is part of the environment.
So let's see. I think we've got questions, but not, the answer to that is need more testing. What else? I don't think we have an answer for that one. Any other questions or comments I should incorporate into this?
Actually, here's a question. What are they going to do about waste? Are they going to bury it? Are they going to store it? Are they going to try to bring it back?
I know.
Turn it into something useful?
I know there's an attempt at the supercritical water oxidation to process it back into useful stuff. I don't know if that's realistic yet.
Actually, I just heard that last part about asking about waste. It depends on which waste you're talking about, but I know that KSC is working on, there's a few different things, but I believe pyrolysis is one of them to do trash to gas. And they're also looking at making it into like anything that's like plastic or whatever related, like building blocks that you could use for radiation protection. Those are a couple of things. And if you're talking about more like organic or human waste, I am trying to work on some things that might work, but possibly I had asked some questions the other day if anybody heard them about biodigesters, anaerobic biodigesters, or aerobic biodigesters, where you would be getting methane off as a product, but you could then use those effluents potentially as a fertilizer product to add to the regolith, which is part of why I'm interested in the regolith growth media. You can add those nutrients back in. So those are some of the things that I just know at a very high level that are being worked on.
Well, I have to really say that doesn't fall under the lunar environment. I mean, yeah, that's the habitat environment, and we are concerned that, you know, we need to work on that for somebody needs to work on that for the astronauts, but that's not really our job.
Right.
Our job is to make sure that the whole, you know, they have a place to live and their suits work. And
unless, of course, they're going to try to bury it, you know, outdoors, and then it becomes a part of the, you know, outside environment.
maybe turn that into bricks or something. Burn it.
Well, yeah.
I don't know.
You have those
I
perfectly
usually say that's biology, that's squishy stuff, and I don't have to worry about that.
Harrison Schmidt said that the perfectly formed holes goes 3 meters deep from his core samples, so that's a big hole he can fill.
Oh yeah, there you go.
Yeah, there's a lot of work that needs to be done.
Yes, there is. Well, unless anybody has other comments for this, I think I think I'm good, and I appreciate everyone's time, comments, and attention and presentations. I think this was a very good symposium.
I do too. It was very well organized, and the talks were excellent. It was maybe one of the very best workshops I've ever been to in my whole career.
Oh, that's saying something coming from you, Sheila.
As I've been to a number of things, but no,
I was about to say I think you've probably been to more than I have. So
yeah, and I mean the only problem I had was my own internet.
Yeah.
But that was not the fault of the conference, certainly. But no, I think everything was well run, and the talks were great, and I've learned a lot.
I did too. I think that's the other thing that I really found valuable was Harrison Schmidt's talk, because really, what's it like there? And he definitely gave us that. So I appreciate that.
He's written a book. I forget the name of it, but he has written a book on his experience.
Okay. All right. Well, I thank you again, and I think I'm going to declare this closed and sign off.